Hello everyone. Welcome to Organic Chemia's today's webinar about new generation ink and clear waterborne acrylic emulsion for industrial wood coating applications. I will be your presenter for today. My name is İlker Kocabıyık, and I am the Technical Solutions Manager for Coating Division of Organic Chemia. Before I start my presentation, I would like to remind you that we will receive your questions at the end of the webinar. If you want to ask a question, please use the Q&A chat box, which is placed on the right side of your screens. We would like to have an interactive webinar by your participation as well. During the webinar, there will be a poll question part. Our poll questions will appear on the same right side of your screens. We would be glad if you can participate into our poll questions and help us better understand the voice of the customers for future innovations. And lastly, you do not need to take screenshots or recording of the presentation. This presentation and technical documents of our product will be ready to be downloaded at the end of the webinar. You can find the download link in the menu on your screens. So please just enjoy the webinar. Now let's have a look at our agenda for today. I will start with a short introduction of organic chemia and later on focus industrial wood coatings market, more specifically waterborne acrylics for wood. Then I will introduce Orgal F4630 properties with some performance results in a clear gloss top coat and in a clear matte top coat formulation. And finally, I will conclude my presentation. Before going through my 30-minute presentation, I would like to make a brief introduction of Organic Chemia. Organic Chemia is a family-owned company, started its journey in 1924 as a chemicals trader. And our company is manufacturer of emulsion polymers since 1965. Organic Chemia today is one of the leading polymer and specialty chemicals producer in Europe with growing portfolio of products. Organic Chemia serves over 2,000 customers in 80 countries. With its waterborne emulsions, redispersible powders, hot melt adhesives, and solvent-borne acrylic products, Organic Chemia serves into a wide variety of industries, which is organized under 6 different business units. Those business units are coating solutions, construction solutions, textile and leather, PSA and paper, industrial adhesives, and life sciences solutions. With its 5 manufacturing locations, Organic Chemia factories have a total capacity of 250,000 tons. Organic Chemia family has over 550 employees worldwide. R&D and innovation are the core values of our company. Organic Chemia employs over 80 scientists in R&D department and spends 3% of its turnover to R&D projects. Organic Chemia's 2 plants, which are in Kemerburgaz, Istanbul, and Rotterdam, Netherlands, specialized in emulsion polymer production. Second plant in Tuzla, Istanbul, manufactures redispersible powder polymers for construction chemicals and hot melt adhesives for several industries. Relatively small plant in Balerna, Switzerland, manufactures solvent-borne products into special industries. So that's Organic Chemia briefly. Now, I would like to start our main topic for today, which is industrial wood coatings. According to different market report estimations, global wood coatings market has a value of 8 billion euro worldwide and have an annual average growth rate of 6%. Although shifting from solvent-borne to waterborne started a long time ago, global wood coatings market is still dominated by solvent-borne. Almost 60% of the total value generated goes into solvent-borne and high solid resins. Waterborne resins in this picture holds 20% of market share. Waterborne resins are mainly composed of polyurethane dispersions, polyurethane acrylic hybrids, waterborne alkyds, waterborne UV resins, and self-cross-linking acrylics. Among waterborne alternatives, self-cross-linking acrylics are widely preferred in wood coating applications. Their relatively lower cost and performance ratio makes acrylics an ideal binder of choice in several cases. Regulations and increasing sustainability demands of customers are the main drivers for growth of waterborne resins. But despite of performance benefits and sustainability value of waterborne resins, why the solvent-borne systems are still preferred for wood coatings? There are several answers to this question, and let me underline a few of them. Drying speed of acrylics is the first major issue to overcome. Especially at low temperatures and high humidities, acrylics are difficult to be cured in ambient conditions. Mechanical properties such as hardness, scratch resistance, and also chemical resistance of acrylics can achieve quite an important performance targets for industrial wood coating applications. However, current acrylic technologies still need improvements to overcome solvent-borne resins in some challenging applications. Ease of formulating an application. Waterborne coatings needs more additives when formulating and as well as during application. Application results are much influenced by ambient conditions, type of the substrates, and type of the application tools. Many additives needed to overcome foam issues, substrate wetting problems, flow and leveling problems, rheology adjustment, and so on. Another aspect is the wet and dry film properties. Solvent-borne resins have a very well-known property, so-called wood warming or grain enhancement, which results into beautiful-looking wooden products. So this historical solvent-borne resin aspect is also asked from the waterborne acrylics by some of the customers, and some acrylics suffer to give this performance. When we talk about waterborne versus solvent-borne, automatically we drive into a more environmental friendly lower VOC area. However, what is the degree of lower VOC performance we can achieve? For example, most waterborne acrylics for industrial wood coatings have MFFD values over 30 degrees Celsius to achieve necessary mechanical properties, and such high MFFD values bring VOC together. When lower MFFD acrylics are used, desired film hardness and scratch resistance properties are not achieved. So we started our new product development journey by listening voice of the customers carefully. Knowing the facts I mentioned about acrylics in previous slides, our innovation team figured out and highlighted 6 key aspects for a new development. Those aspects are excellent wet and dry film clarity, closer to solvent-borne resins, lower VOC capability, and at the same time achieving industrial wood coatings performance, excellent film aesthetics after spray application with excellent flow and leveling properties, grain enhancement and wood warming performance close to solvent-borne resins, enough chemical resistance requirements, if possible IKEA R4 or even R2, and easy matting performance. Our product, Orgal F4630, is a low particle size, translucent emulsion developed by Coating Solutions R&D team of Organic Chemia. This low viscosity acrylic has 40% solid contents and a low MFFD value around 20 degrees Celsius. By the help of a novel emulsion polymerization technique, Orgal F4630 is formulated with ultra-low surfactant content. It has self-cross-linking ability to achieve chemical resistance and as well as hardness and scratch resistance properties. Its heterogeneous morphology ensures high block resistance properties with low MFFD. Ink and appearance of Orgal F4630 can be seen in this picture. As seen on the left-hand side, the black background can be seen through translucent appearance of Orgal F4630. Such visual property is not possible with some conventional acrylics. So let's have a look at the application areas. Orgal F4630 can be used in several application segments for wood coatings. It is both possible to formulate sealers and clear top coats, and as well as opaque primers and top coats for industrial use. Its low MFFT property makes Orgal F4630 also a very good alternative for premium decorative wood coatings, such as trim paints, low and high film build wood stains, varnishes, and enamels. Well, now first, let's have a look at the coalescing compatibility of our product. Film formation is the key stage for waterborne acrylics to achieve best of the performance we will get. Some of our customers would know it very well that it is no surprise to see improper film formation behind some of the unexpected bad results. Therefore, we need to know coalescent interaction of our binder to make the optimum choice for our coating formulation. Our product is tested with majority of coalescing solvents widely preferred by wood coating customers for industrial and as well as decorative use. As seen from the table, DPMB, butyl diglycol, and TPMB were not found compatible with our binder. Other listed solvents can be preferred and can be used in 3 to 5% level on total wet polymer. But there is a rule that we should always remember. Amount of coalescing agent should be determined by later studies for specific formulations and application conditions at the customer site. Pendulum hardness values, another important property to assess early properties of acrylic emulsions, which is essential for industrial applications. Especially high early hardness values are used as an indicator for fast drying, early stackability, and early scratch resistance properties. Pendulum hardness development of our product is measured with compatible coalescing solvents after several drying periods. As indicated in dark blue and green bars, butyl glycol and PMB gives highest early hardness development values after 5 hours of drying, and this similar trend continue up to 14 days. In this part of my presentation, I am going to use a market benchmark for a while. Market benchmark acrylic, which is also known by its good ink-and clarity and low VOC capability. Benchmark acrylic also has 40% solid content and MFFT value of 15 degrees Celsius. We have tested film clarity and wood forming properties on 3 different wood types. Our first testing wood was oak. Those pictures are applicator drawdowns by 200 micron wet film thickness. On left-hand side, wet appearance of clear top coat formulation just after applicator drawdown is seen. And on right-hand side, film aspects after drying is shown. Orgal F4630 shows no whitish aspect in wet state and has excellent wood forming after drying. Mahogany is another popular wood type which is used especially for assessment of wood forming and grain enhancement properties. Excellent wood forming property of Orgal F4630 is much easily seen on this wood panel. Last tested wood was beech, which shows wood forming relatively less compared to previous wood types. Despite of this fact, similar good wood wetting and grain enhancement performance was achieved. Now, we are going to see some performance results in 2 different formulations. We will use clear gloss top coat formulation to assess performance of Orgal F4630 without any matting additives. And in the last part of my presentation, I will share some performance results in clear matte top coat to better understand formulation optimization possibilities. In gloss top coat recipe, we have 70% of binder and a coalescent blend of DPM and PMB. Thickener package is used in pre-diluted form to improve compatibility and avoid shocking during incorporation. Early block resistance was tested with both gloss top coats after 30 minutes of drying and 60 minutes of drying in 50 degrees Celsius in order to simulate forced drying conditions. 1,000 kilograms of weight was applied per meter square. In a 0 to 10 scale of assessment, and 10 being the best performance, both binders were found 7 after 30 minutes of drying and 8 after 60 minutes of drying. 7 and 8 means panels were able to be separated with a gentle force and surfaces were not damaged. For an industrial wood coating application, good blocking resistance results were achieved. Chemical resistance is tested according to internal methods that covers both DIN 68861 norm and EN 12720 norms. Actually, both standards are almost similar, except the biggest difference being the numbers used during evaluation. Clear coats were applied 2 times, 200 micron wet on each veneer, and sanding process was applied in between 2 coats. Panels were dried at least 7 days in room temperature before testing. Chemical resistance assessment is done in 0 to 5 scale. Detailed evaluation criteria can be seen near the table. I would like to remind you that we are testing transparent coatings here, and type of the substrate and color of the substrate is directly related with the chemical resistance results we will obtain. In this case, the substrate applied is a beige veneer with natural wood color, which means that the natural color of the background may interfere with coffee stain and some of the other stains. So let's have a look at our table and see what is achieved. Both binders performed almost similar, except for the ethanol resistance after 16 hours. Orgal F4630 has a score of 4, where competitor acrylic is 3. As it will be important for the IKEA test results in my following slides, I will also underline ethanol resistance after 1 hour, which is 4, and water resistance after 16 and 24 hours, which are 5. Some basic mechanical resistance tests were also performed. Coin test is a very historical but still an important test that wood coating customers prefer to do it for early impression of the surface hardness. On left-hand side, we can see a coating which shows poor performance after coin testing. It is by far too hard and brittle, which means it will fail to tolerate the impacts. And on the right-hand side, we can see a coating with good performance after coin test. Coin test results and as well as nail hardnesses with both binders were found good. Another important aspect, sandability performance was also very good. It was easy to sand, and no dust, no sanding dust was sticking on the sandpaper. As previously mentioned, waterborne acrylics are much sensitive to application conditions and needs much care of the formulation compared to solvent-borne resins. But this general situation here is not the case with Orgal F4630. Excellent flow and leveling property is one of the strong characteristics of our product. This picture shows dry film appearance of clear top coat formulations with 4 different acrylics. I would like to pay your attention to the reflection of fluorescent lamp on the surface. Waterborne acrylic 1 and 3 show much intense orange peel effect, and waterborne acrylic 2 is even worse. It is almost matte appearance after spray. However, Orgal F4630 based top coat clearly has best visual aspect. Our product has excellent spray atomization, which allows easy covering of the surfaces even after one pass with spray gun. Orgal F4630 has excellent emulsion stability against mechanical forces, which allows application of coating formulations by high-pressure spray guns and as well as roller coaters and flow coaters. Thanks to its ultra-low-level surfactant content and Newtonian rheology, which gives easy defoaming ability and even film surface after application. In the second part of the performance test, I'm going to use clear matte top coat recipe. We know that gloss systems have very small market size, and the majority of the clear coats in the market are matte. When matting agents are introduced into the system, they bring new challenges together. In most cases, chemical resistance is negatively influenced and film transparency is lost. Our new formulation is almost same with the glass top coat recipe. Different matting agents are added at the end of the production separately. Gloss levels around 15 to 20 were targeted at 60-degree angle in this exercise. 8 different matting agents were tested, composed of 3 different micronized waxes, 3 different silicas, and 2 different wax dispersions. Micronized wax 1 is a silica-coated polypropylene. Micronized wax 2 is a pure polypropylene, and micronized wax 3 is a modified organic polymer. Silica 1 is a popular untreated thermal silica. Silica 2 is a polymer-treated precipitated silica. And silica 3 is another wax-treated precipitated silica. And lastly, wax dispersion 1 is a modified functional blend, and wax dispersion 2 is a non-ionic polyethylene dispersion. Micronized waxes were used 4% on total weight of the formulation. Silica matting agents were initially added 2.5%. However, amount of silica 3 was increased to 3.8 to achieve target gloss levels. And lastly, wax dispersion 1 and wax dispersion 2 was used 4.3 to 4.4%. As seen from our table, average 15 gloss units, gloss levels were almost achieved with all samples. Matte clear coats were applied on each veneer 200 micron wet 2 times. And pencil hardness values were measured. Highest hardness value of 3H was measured with all silica types and also with micronized wax 3. Remaining micronized waxes achieved softer pencil hardness value, which is 2H, and the softest value, H level of hardness, was measured with both wax dispersions. Similar tendency was also observed with pendulum hardness values. Over 100 conic hardnesses were measured with silica types and relatively lower values with wax dispersions. Now, let's have a look at the most important performance results and interesting results with matting additives, which is chemical resistance. For this test, special wood panels were prepared as seen in the picture. A white opaque wood stain was applied on top half of the beach veneer panels, and the black colored stain was applied on bottom half of them. On these black and white panels, matte clear top coats were applied 2 times with 200 micron wet film thickness again. In order to observe color changes carefully, coffee, mustard, and red wine were tested on white background, and with a similar logic, ethanol, water, liquid paraffin, ammonia, and vegetable oil were tested on black background. Having a black background also helps to differentiate matting agents in terms of film transparency and widening effect, which is an unwanted phenomenon. As easily recognized from the picture, film transparency performance was almost perfect with wax dispersion 2, and it was worst with silica 2. In MET systems, IKEA chemical resistance requirements were also checked, and assessments for R2 and R4 performance were made. According to IKEA norm, IOS MET 0066, in a 0 to 5 scale, 4 is acceptable result for chemical resistance. It is well known that having R2 requirements is a bit tough target to achieve with self-cross-linking acrylics. However, when we look at our results, we see a surprising result with wax dispersion 2, which achieves R2 requirements. All the other matting agents fail for R2 because of 24 hours of water resistance. When we look at the R4, micronized wax 2 and again wax dispersion 2 also achieves R4 requirements, and again all remaining matting agents fail because of 16 hours water resistance testing. This study shows us the importance of matting additive selection to achieve surface protection properties. Hardness, film transparency, and chemical resistance properties of top coat formulations based on Orgal F4630 can be optimized to match the performance requirements of demanding applications. I would like to inform you that in case of an optimization need, our technical team is also ready to assist you in your important projects. And lastly, early block resistance performance was tested again after matting agent adhesion. The two bars on the left-hand side remind us the results we achieved with clear gloss top coat recipe in our previous study. When matting agents are introduced, it also improves the block resistance to an almost perfect level, which can be seen on the right-hand side. In conclusion, our new product, Orgal F4630, is excellent choice for transparent wood coatings with its outstanding clear film properties. It is a very good alternative, a waterborne alternative, to introduce customers whose expectations are close to solvent-borne aspects. Thanks to its low MFFD, which makes it suitable product for both industrial and premium decorative applications. Depending on the application conditions and formulation parameters, it is possible to achieve performance of demanding standards like IKEA. And last but not least, Orgal F4630 promises wood coating applicators easy formulating and easy application performance under challenging conditions. This was the end of my presentation. I hope the webinar was informative and useful for your wood coating applications. I would like to thank you all on behalf of entire team members who is behind development of our product and preparation of this event today. If you need further information and samples of Orgal F4630, you can contact our sales force in your region or send us emails directly. I guess now we can start Q&A session, and let's have a look if any questions exist in our chat box. I will try to answer most of your questions now. However, if additional information is needed, we will answer you soon by email after the webinar. So let's see if we have some questions in our chat box.